Welcome back to part 2. Made some progress, a lot of progress, in one day. So I finally decided on how the front panel is going to be mounted, and I can't wait to show it to you. So what I did is I bought these poplar dowels, and I slit them, made like a dado joint with my table saw that the plexiglass fits right into. And there's one on either, on the top and the bottom. The plexiglass is going to sit in the frame. Now, in the process, I also solved one of my cooling dilemmas. I'll demonstrate. So, we know that the intake air for the CPU cooler is going to be coming from behind. It'll actually be coming from the bottom. Well, the bottom. I'm going to have a slot. So if this is sitting up against the wall, there will be like a 1/2-inch slot behind it that will allow air to come through. Now, the question is, where does that air go? It's going to rapidly pressurize the cabinet otherwise. The exhaust fan on the power supply is only so powerful. It is much smaller with less airflow than this guy here. So we're going to be having fans fighting each other for air. Well, this one's going to be pushing air against this one. Not a good situation. So my solution was to provide vents on the side over there that will help equalize the pressure. So excess airflow can go that way. I don't like the idea because it adds more holes into the casing. And more holes means more complexity or it takes away from the visual of the inside. I don't like it. It's ugly. I'm going to be Steve Jobs for a second. I then realized that there's another way. You son of a bitch. You heard me, didn't you? You leave those LEDs alone. As I was saying, I solved the problem, and it's actually quite, I don't want to say brilliant, because that would sound too, I don't know. It's not a brilliant idea, but it is a solution. So let's pretend that this is installed in the cabinet, and the cabinet walls, the top and the bottom, are against here and here. There's going to be a 1-inch gap from the bottom of this dowel to the floor and the ceiling of the cabinet. Now what that will do, if you can picture this, is cold air will flow in from the bottom, and then hot air will flow out from the top. I believe that is convection is the correct term for that. And what it does is it provides a steady flow of air through the case. The hotter the components become, the more the air rises, the more cold air is drawn in from the bottom, and it just cools itself. That means that the display and the other components that aren't cooled by the heatsink are essentially taken care of. The hard drive, which is on the top, oh, it's brilliant. And it's so simple. It's so simple, it's brilliant. Now, you might be wondering, how is the plexiglass going to be mounted in the case? Well, basically, these dowels are removable. The bottom one, I'm actually going to glue the bottom one in place so it can't be taken out. But the top one will be removable. All you do is, these dowels are going to go right through the sidewall, and they're going to pin it in place. And I use the same size dowel to make these knobs, so that way it's going to look like a continuous dowel going through, but it's really not. And these dowels are going to be painted silver. In fact, now I'm going to take these off the cart right now and get these painted up, and it's going to be awesome. I think so. I think so. As for the side panels, or the outer cabinet frame, the outer frame has been, I'm painting the inside first, and then it'll be reassembled and installed together as one unit. Once that's done, in fact, we're actually at that point now. Why don't we do that? Yeah, let's do that. One of the challenges with building something like this is components need to be installed in sequence. You have to think ahead. Okay, if I assemble the whole thing right now, can I still access this fastener here or that fastener there? Can I install this component or that component? And you're going to find the answer is no. So you have to make sure that you plan ahead and you start mounting components like the speakers, for example. They're going in the top. And I had to cut a 3-inch hole. And I have to solder the wiring for the speakers first. I can't do that later. That has to be done now. So yeah, things like that, you have to really think ahead and get these things done. Got to get that box back apart. We're going to cut the slot off the back. I'm just going to take the bottom board off. So we're going to do that now. So I got the bottom board removed. I've got it cut down to size right there. And while I'm here, I want to experiment with the placement of the amplifier board and see if maybe we can rectify the noise issues that way. So I've got it all taped off. We are going to start sanding the box on the exterior. This is the side effect of building something from the inside out. You finish the inside, get all the wiring laid out, all the components put together, and then once that's all said and done, the inside's painted, looking pretty, then you go to the outside. And I did it this way because if I were to have finished the outside first, and I had to take it apart to work out more stuff on the inside, as I had already done a few times, to make some changes. One example being I had to cut out a slot. This was not part of the original plan, of course, there was no plan, but anyway. I had to cut a slot out of the back board so that there is a nice path for air to come in through the back for the CPU cooler. So what I'm saying is, if I had finished the exterior and then I had to go back and make changes on the inside, I would have cracked the finish, first of all. The other thing is I'm trying to make these, I want the corners and the nail holes to be invisible. What I mean is I don't want there to be any visible seams when this is said and done. So that's why I'm going about it this way. So at this point, it's fully assembled. I've actually added some screws to the frame to keep everything nice and secure. Finished nails can only go so far. That's when you start looking at other fasteners that might do the job a little better than those. So that's why we used, I used finished screws. There's small, a finished screw looks like this. Small head. These are stainless steel. These are expensive. But anyway, I used those to secure the end pieces together. I've also added a few additional finish nails to keep the board in place. We don't need any screws or anything heavy duty to keep the board set in its position, so I used finish nails for that. Now this was a little bit challenging to make because I had to take, this is a section of the original LCD frame that I had to cut out with a, I'm going to use my Dremel tool and a miter saw. And it was never meant to be mounted to anything, so I had to cut off a lot of plastic. This is a capacitive touch control panel. Very interesting. And the connector's right there. Just about to see it right there. I may actually have to router some of that out to get it right. A little bit off. And this is an automotive, this is actually a starter button. I got that at an auto parts store. And that's going to be the power button for the PC, and of course if you wanted to power the monitor off, that's how you would do it. But this is the actual control panel from that monitor. This is going to be mounted, I'm thinking, I'm going to mount it actually on the top. And it's vinyl wrapped. I mean, not the cleanest job, but it's better than what I was doing. The thing is, the stuff is so thick, it's very hard to work with. It doesn't really want to, it's not probably, I'm sure there's a better material to wrap something like this with, but this is what I have. So I wasn't going to go out and buy anything else. And now we have some color. Look at that. Now it's got a little bit of color going on. And that is the classic red paint color that I chose. Now I sanded, so after reassembling, I think I mentioned this earlier, I screwed it together and I sanded every seam smooth. I added wood filler where needed and sanded where it didn't. And that is what I came up with. So I think it's looking pretty damn good. Now I just need to get those bars painted, and then we can do a quick test assembly of the unit. I can't put it upright until this has a chance to fully cure. Because if I put it upright right now, it will, the paint will just get ruined. So this has to be, this has to cure for probably a good 24 hours before I can do anything else to it. But you get the idea. Okay, so we had a few changes. What we've done here is we've added a ground strap from the power supply to the hard drive bracket to the logic board, because I think that I know there was a floating ground. I checked it with my multimeter. The hard drive casing wasn't grounded to either the power supply or the logic board, and the power supply shell wasn't grounded to the logic board. So we had a bit of a floating ground situation here that could be, you know, whatever. So let's just see if it made a damn difference to the audio system. Got my tone control, there's my volume. You can hear whistling. That's normal. Yeah. It's still horrible. That's just unacceptably bad. Yeah, I don't know what I'm going to do about that. I just don't know. Well, this didn't come out as neat as I'd like it to. This was mainly the result of this being kind of an afterthought. So I did get some tear out, and I couldn't drill from this direction because I can't take the display out. I mean, it's just, you know, a whole big thing. But the new control panel is installed. A couple of things just showed up from the land of China. This is a fan controller and status display. And I bought this not to use it for controlling fan speed, but more for a visual effect, because it displays the date and time in addition to a couple of other data points. It is a replacement CPU fan. This lights up. Yeah, baby. And apparently it also requires additional power, which I have removed from the fucking power supply. In other news, I have these holes in the top for the speakers. And I got to thinking, why don't I get something to finish those holes off with, like a bezel or something, and this is what I'm going to put in there. Now these are actually designed for desks, and these are those grommet hole things you put in your desk. But these can be painted to match the paint that I'm going to use on those bars. And they're just going to sit right in here. They're friction fit, 2.5-inch holes. Look at that, doesn't that look nice? I've been talking to my coworker about my audio system problems, and he agreed that it's definitely RF interference, but he offered a solution. He says, why don't you try a shielded audio cable? So I ordered one on eBay. We'll see how that see if that helps. You know, I might just leave these black. That actually kind of looks nice. It kind of blends in with this control panel, and it looks pretty good. I think I like it. I think I like it a lot. Alright, so I've got this controller mostly plugged in and installed. I decided I'm going to install it right about here, so it'll bring some visual attention over to this side of the case, and you can see it through the plexiglass. I'm going to leave it in the 5 1/4 inch mounting plate. It gives it a nice finished look, so we're gonna do that. We're gonna dress these wires up a little bit better. I've got the I actually had to graft a Molex plug strip or plug from the old case that I had already chopped off. I had to I just spliced it on to the to one of the SATA controller plugs, or I'm sorry, SATA power plugs. So I could plug this in, plug the fan lighting in as well. The lighting on the fan is just an LED, a series of LEDs in a ring, and it's powered off of the 12-volt bus, which is why they couldn't run it off of the 3-pin fan connector, which is obvious. Everybody knows that, and I know that, and I just wasn't thinking. Anyway, before we start this machine up and give it a good test, I want to say something that I feel needs to be mentioned. So, all right, the purpose of this build is not to build a performance gaming rig. I am not building a machine that will even be used for even the remotest of desktop applications. The only thing this machine's job is to do is to play a video on loop. Now, the cooling system I really carefully considered because I don't want it overheating, but I also don't need to overcool it. And I've designed the system in such a way that, and I believe with this fan, unfortunately, I can't flip it around. Yeah, the old fan was installed, was it sunny side up or sunny side down? I don't remember. But I'm hoping that it pulls air from the back through the radiator. There is more than enough, the hole is far big enough to pull enough air through that radiator to keep the system cool, even under, I believe, even under intense applications, but that's just my opinion. The airflow from the back will be supplied by this half-inch slot that extends the whole width of the 4-foot. So if you multiply, let's see, is that 1 half-inch divided by, or times, what is that, 48 linear inches? 48, that's 24 square inches of cooling capacity, airflow. There we go. That's a 24 square inch path for air. That's big. That's huge. To allow more than enough air through the back when it's mounted on the wall. This is a 6-core processor. It won't even break a sweat doing what it's going to be doing. It won't even be connected to the internet. The wireless will be turned off when it's up and running. I'm not worried about the heat. Now, the passive cooling, or the convection cooling, for the display and any other components like the chipset, the BIOS chipset, or the Northbridge, the convection cooling works as follows. Hot air rises, everybody knows that, and it's going to rise through a 1-inch wide slot along the top edge. Now, to provide makeup air, there is a 1-inch slot on the lower edge for cool air to come in and flow like that. It's going to work just fine. This is being installed in an air-conditioned office. My point here is that cooling is not a concern for me. It just isn't. Now, all of these parts, well, except for this, were crammed along with a second hard drive. There are 2 hard drives, this board, this cooler, this power supply. Did I say 2 hard drives? A CD-ROM drive, and God only knows what else, were crammed into that little box over there. That is where these parts came from. And there is little airflow in this case. This thing, and it was stuffed in my entertainment center. Now, you're going to love this, but it was running for 5 years, uninterrupted, as you see it. No issues. Running a Plex server 24/7. It'll be fine. Now, let's power this thing up and see what all these Chinese goodies do. That is not the best fan. I'm sure that fan is going to last all of maybe a year. Ooh, that's pretty. Oh, there goes the furnace. That is pretty. And look at that. I love the visual effect there. But in real Chinese fashion. So this is now running our water cooler. So I can see the water cooler. Okay, so now it's hooked up correctly. So CPU, cooler. I can change the speed just by pressing this button. That should lower it a little bit. Seems to a little, just very little. Change this to Fahrenheit. I think I hold this down. There we go. So 61 Fahrenheit. But if I put my finger on this, it will detect that it's not spinning anymore. And there it goes. You can feel that going. It almost doesn't look like it's changing the speed at all. It doesn't display RPMs or speed, actual, tangible speed numbers. So the hard drive, so it remembers, so if you start it up and you don't turn something on, or like you have a fan disconnected, it acknowledges that and it won't give you an alert. Okay, so we'll reset the alarm on that. And system, that's the water cooler. I'm going to lower that down a little bit. Just make sure I have this in the right channel. So if I stop it, the alarm goes off. And there it goes. Okay, so we've got the hard disk drive thermal sensor mounted. I've got all the wiring routed in this loom here. It's a bit packed. I gotta be honest. It's a little bit more wire than I was anticipating to run over here, but I'll get the air compressor out. We'll clean it up. We've got the fan connectors all plugged in. I've got my that's connected there. Again, it's a little bit busier than I had anticipated in the end, but let's see. The only thing we haven't done is we haven't routed these two thermal sensors. One of them is for the housing itself, and the other one is for the CPU, which is I can't connect it to the water block. Interestingly enough, I believe there's no, that's not. I thought that was a thermal sensor. No, it's not. But I'm going to put it in the radiator. I'm just going to shove it in between the fins and wrap up the remaining cable. This is very, very cheap looking, but that's okay. It works. Let's adjust the speed of the CPU fan. Okay, that is connected to the water cooler. I gotta reverse those two. This one connected to nothing. Yeah, it doesn't change the speed of that fan though. CPU, hard drive. Set that to Fahrenheit. This is our hard drive indicator. That's our power indicator. Of course, there's nothing on the other end of that one, so that's not going to do shit. I gotta set the clock though. Yeah, we gotta do that. I gotta figure it out. The instruction manual is written in Chinglish, so I can't really understand it. So I'll have to figure it out. But look at that, it's up and running. Now, I also went in and I fixed the connector for this lower strip of LEDs so that they light up in the correct color. I had them reversed on purpose and I decided against that. So let's cycle through the primary colors: red, green, blue. So that works. White, green. The gradient colors are a little bit iffy though. That's supposed to be purple, but it turns out to be not purple. That's light blue. It's more of a green. So yeah, it's not perfect, but I don't want to screw this up. This is an expensive cut. It's a $30 sheet of plexiglass, and you screw it up, there's $30 down the drain. That adds up fast. Always make sure that you measure twice, 3, 4, 12 times. Otherwise, there you go. It's a clean cut. There's no melting of the edges or anything crazy like that. That's a good sharp blade that I'm using. So let's hope it fits. Now I'm going to present to you guys the finished final I'm doing nothing more project. I've gone through and I've trimmed off a few things. I've buttoned up and neatened up some stuff. The last thing I did was this. I had this gap between the top and bottom of the SD card reader, and I filled it in with dowels. These are 1/4-inch dowels that I've cut to size. Of course they're not perfect, but painted them silver, same color as the dowels and the dowel pegs. Moving our way to the front and top, you'll see the speakers are mounted with desk cable grommets as trim to trim out the holes on both sides, left and right. Also on top we've got the completed control panel that has been vinyl wrapped. This is literally a section of the front bezel of the original donor LCD monitor frame that I cut out with a Dremel tool and modified, and I recessed it into this piece of wood with vinyl. This is a automotive starter switch. I got it for $10 at O'Reilly Auto Parts. The face of the machine is simple Lexan or plexiglass mounted in 2 slotted dowels. These are 7/8-inch dowels. The end pins were made from a section of dowel and a 1/4-inch dowel as well, kind of drilled into it. I've pointed the ends with a pencil sharpener to make them easier to locate the holes. It just makes installation a little bit easier when you're putting it back together again. Let's go ahead and mount it on the tripod, and we're going to take a look at the inside. Okay, on the inside, to get into the inside, simply remove the end pins, and you're going to tilt the plexiglass forward while maintaining a downward pressure on it so it doesn't fall out of the bottom rail. Then you're going to use your 4 fingers and you're going to pinch the plexiglass while pulling or holding the dowel to the glass. You're going to lift straight up like that. That is how you remove the plexiglass for access to the internals. Starting from the left, we've got the multi-card reader mounted to the board. We've got the fan controller temperature monitor mounted here. Now this also serves as an alarm should one of the fans or, for example, the CPU cooler pump fail to produce a tach signal, meaning that it stops spinning. I will demonstrate. And after a few seconds, it starts to produce an audible alarm. Once the situation is rectified, the alarm goes away. It does not display the fan speed in revolutions per minute, but it does display the temperature as read from the temperature sensors in either freedom units or Celsius. I have 3 temperature sensors located all around the system. This up here, you can't really see it, and that's the point, is the system temperature sensor. The thermistor is poking right out into the cabinet space. There is a second thermistor mounted to the bottom side of the hard drive, and let's show you what that looks like. It is 83 degrees freedom units. There's a third sensor that is in a controversially placed location. It's not really telling you the CPU temperature, but it is telling you the intake air temperature. And that is going to be 59 degrees. That's room temperature right now. The power supply is mounted to the board and trimmed out in this lovely shade of hot pink. The same hot pink that the monitor frame is painted in, but we'll get to that in a minute. All cabling is routed and managed using a series of either zip ties or cable mounts in varying sizes depending on the cable size. I have 3 different sizes of cable mount, from large to medium to small. That was an enormous feat in Home Depot and Lowe's trips that took many, many weeks. Cooled by water. And this is a very simple self-contained cooling system. It is sold as a sealed unit in that you cannot add or remove coolant. You cannot change the hoses. You could, but it would be pointless. There's no reservoir or anything like that. This is designed to be bled from the factory. It works fantastic. As a matter of fact, this cooling system was in service in my living room, in my home theater PC, which is what this once was, for about 5 years without any incident. Never once did the CPU overheat or come even close to it. And while we're talking about the CPU, we've got a 6-core AMD Phenom X6. Phenom 2 X6. I'm not sure of the exact maximum clock speed, but I assure you it is nowhere near it. It's running at a fairly idle speed right now. This machine will never break a sweat in its intended use. As a matter of fact, I wouldn't personally have a problem putting anything intense on it. I think it can handle it. But it is fitted with new thermal paste. The thermal paste that I'm using is actually Apple OEM thermal paste. It is what is used for servicing the current generation Apple products. That doesn't make it good, but it's what I have. And I tried to spend as little money as possible. Unfortunately, a lot of the money went into the cabinet work. The plexiglass, the wood, the hardware. That's where all of my money went. No money was spent on any computer component at all, with the exception of the CPU, or the radiator fan. I wanted the fan to glow in violet, and that is why I have this. It's not the best fan in the world. It was the cheapest one I could find, but it's doing the job mightily well. And should it ever fail, I have a spare. The one that came on the cooler originally still exists. Moving on. It does have a StarTech 80211G. I believe it's an N card as well. Probably not. Anyway, whatever the case may be, I think it is an N. I don't remember. It's a PEX 300WN 2x2. I'll have to look it up. It is mounted to the board using a homemade mounting bracket. Let's take a look at that. The bracket is made from basically erector set pieces that you find at the hardware store, and it's adjustable. But I used nylon spacers to achieve the result I needed and the height I wanted. I had to space it off the card so that it doesn't short out on those pins. That's what that spacer is for. And it's screwed directly to the board. There is a wire soldered directly to it that leads to the clandestine chassis mount, or ersatz chassis mount chassis ground, my bad. The ersatz chassis ground, which is just I believe that's a 12 gauge copper wire that is bent in a variety of shapes to connect the power supply to the hard drive to the logic board. So I tried to reduce the number of floating grounds that we have for a lot of reasons. The board, by the way, is a BioStar TA785G3HD. I don't recall the specs on this board. I did not buy this board. It came in a system that I bought used back in 2011. So she's been around the block. She's been in no less than 3 or 4 chassis in the time that I've owned her. She started out in an Antec 300 case, and I moved her to a slightly smaller ATX case. I then moved her to a home theater, a dedicated purpose-built home theater case. After that, I moved her to the, I believe that Landbox Light case over there. Although I think there was another case in between. As I've needed the board for different applications, it has changed form many times. She's had 2 processors in her. The first processor was an AMD Phenom X4. And then I found the X6 and the water cooling system in the trash, and that's where that came from. So no money was spent on that. And there you go. For permanent storage, we've got a Hitachi 500 gigabyte drive. I believe this drive came with this board originally. It was in that system. But the drive's been fairly reliable as long as I've owned her, and that's what's in there now. I had intended to build a clear RGB. Oh, this is so cool. This drive was supposed to go in this machine. Now, this was part of the original build video, video part number 1. And I had gone through the process of taking this ordinary Western Digital 500 gig drive and turning it into a clear covered drive. And I ran into a variety of problems that all led to the drive failing. I did 3 of these drives. I had a bunch of them sitting from leftover projects and such. And one of them was brand new. I think it was this one. Brand new drive, never used. Anyway, it's a sad story. So the first one I did, I got some dust on the platter. And I didn't have any compressed air to blow it off with. And the dust occurred immediately after cracking the seal. There should be no vacuum in these drives. They are not sealed. I'm going to shut this off, and I'll explain that in a minute. What happened was the drive, for whatever reason, as soon as I cracked the cover loose, dust got on the platter. I could see it as I peeked in there, and I could see dust on it. I went forward and I cut the window. This is actually window glass from my bathroom window when I swapped out the original clear glass with frosted. And this is what I was intending to use. So I actually cut this myself to size, put it on, sealed it up, fired it up, and the drive ran for like a couple of minutes. I was able to format it up to about maybe 5%, and it just died. The second drive, I did the same thing, only I did it in a clean environment. I actually tried something not so clean. I tried it in a steamy bathroom. So I ran the shower for like half an hour to get the humidity up, thinking that might keep the dust down. It didn't. It was a far worse proposition, because what was happening was I failed to let the drive reach the temperature that I was working on it. So I brought a cold drive into a hot bathroom, and guess what happened? I cracked the cover off, and water droplets started appearing on things. And that drive, I fired it up, and it didn't really make 5 seconds. Drive number 3 is this one. I did this one actually in this office right here. I had 0 dust. I had a can of air next to me, and when a little speck of dust landed on the platter, I'd blow it off, get rid of it. I put the cover on, I fire it up, and I noticed something this time. I noticed that the heads were vibrating a little bit, just a tiny bit. And then it hit me. I wasn't putting this air filter in position, and that air filter is critical to direct the airflow into the path of the heads as the disc is spinning, which creates the Bernoulli effect, or allows it to happen. That was my mistake maybe even the first and second times. So this drive, I took it back apart, and I glued the filter to the bottom of the glass in the exact position that it was originally. I fired it up, and guess what? It ran better. This time, it actually made no noise other than the spinning of the disc and the clicky of the voice coil. I got it to format up to 10%, and then she ran out of steam. I could hear the heads vibrating again. So here's the thing about hard drives. Okay? Here's where I went wrong. I know that you guys, you like to throw out your opinions and jump on the keyboards, but I'm telling you, I know where this went wrong. It's not dust. I wasn't using magnetic tools, so knock it off. The problem here is that if you look at how the drive is constructed, you'll see I put the screws back where the original cover was. So the original cover, it hugs so close to the spinning platters that it allows proper airflow. It's an airflow problem. It is not a dust problem. It is not a magnetic screwdriver problem. It is an airflow problem. I actually raised the height of the ceiling. I raised the ceiling so that airflow is going all helter-skelter. It's not being concentrated where it needs to be concentrated. It's going up and above where it needs to be, and it's screwing up the aerodynamics of the heads. And that is where I went wrong. Otherwise, this drive was a running drive. It actually ran up to 10%, and then you can hear it. It was hitting. The heads were ringing a little bit. They weren't getting enough lift to skate over the platter. So I gave up on the clear drive mod. I've decided that it's not for me. It would be cool as hell to have it. Imagine how this would look right here. Now I know what you're thinking. I thought of it. I actually almost did it. I was thinking about putting it in anyway and just plugging it into power and not hooking it up to the logic board. So I did that. I really did. I plugged it into my external drive dock without any data connection to see how it would behave. And what was happening was the actuator was driving the heads up and down, up and down, up and down, and then all of a sudden it would stop spinning. What's the fun in that? You got a clear drive that doesn't spin because it just times out. It's not finding track 0 anymore. It's done. So it just spins down. So that's kind of what happened there. I decided that no, I'm not going to do that. Because what I was thinking of doing is either getting a solid state disc and tucking it away somewhere, maybe behind or something. So get a solid state disc in there and just use that for show. But ultimately it wasn't meant to be. I've decided to just stick with the original 500 gig drive. It works. I'm not putting a solid state disc in here because what's the fun in that? They don't really leave a mechanical drive is paid for. I look at it that way. And for what this machine is going to be doing for the next 10 years, it'll be fine. I swear to you, it'll be fine. Moving along. The audio system. Now, you can hear, as I turn this on, you can hear a slight EMF problem. Now, I think I know where it's coming from. I believe the electromagnetic frequency contamination is coming from, honestly, I think it's coming from the SATA cable. It coincides with the activity of the drive. You can hear that clearly. It could be, some of it was coming from the wireless card, but not much. This is, believe it or not, the improved version of what we had before. What I had originally in here was an amplifier board from the same speaker set that I pulled these out of, these drivers from. They were Altec Lansing desktop speakers. Sadly, they were a brand new set from 1998 or so. And I had just bought them for something else, but I needed speakers and I needed them now. So, and I needed shielded speakers because I didn't want, magnetic speakers that would just start screwing with me. So I cracked the speakers open. I found that they fit perfectly. I pop them in. And I was going to use the Altec Lansing amplifier, and I decided that it was just not fitting. So what was happening was you would hear, like, it was like this times 10. It was awful, absolutely unbearable. The amount of interference was just crazy. And after trying a few things, short of mounting a metal screen around the logic board and the hard drive, which I'm not doing, short of that, I grounded everything out. So I added this auxiliary ground or clandestine case ground and started grounding all the major components, and it didn't help. I added a grounded bracket for the Wi-Fi card. It didn't help. I bought a shielded 3-foot audio cable, and it didn't help. I'm running out of ideas here, so I'm like, well, what next? What's the next step? Potentially snap-on ferrite beads. I'm actually looking at getting a set of those. I'm going to try putting a ferrite bead on the audio cable and the power cable going from the power supply. There's a custom power cable that goes directly into the power supply that I put in there. That could be a culprit. Very well could be a culprit. So I'm going to do that. I'm going to do some ferrite beads. They just snap right over the cable. They come in a variety of shapes, sizes, and colors, flavors. Take 2 before breakfast, that kind of thing. Anyway, we're going to try that, but I'm okay with this. I mean, how many sets of computer speakers do you have in your home, or that you've had in the past, that had a slight interference problem regardless of what you did? I can tell you from first-hand experience, I've been computing since the early 90s, and every computer that I've ever owned, laptops and desktops, including some very modern ones, have had some level of interference. It's unavoidable, unfortunately, and hell, I don't think my MacBooks have had that problem, but my PCs have, and it's just an unavoidable reality of what I'm doing here. I'm running an open system without proper RF shielding, and there's no case. Really, there's no metal case. The back is lined with foil, but that doesn't help. That just prevents or reduces the amount of RF emissions or EMF coming out the back. But that's not really that's, you know, whatever. So nevertheless, I'm going to live with it. In fact, when you're playing music or whatever, it sounds fantastic. I actually have been listening to it all day. Well, not all day, but all night after work. I came in, I cranked up some fusion jazz, and I'm loving it. Sounds great. Not as good as the Altec Lansing did when I hooked it up to my iPhone and there was no interference, but we won't go there. The Altec Lansing amplifier was way better than this. Now, this amplifier came... So I didn't really talk about that, did I? This amplifier was my last resort. I'm like, I've got another amplifier. Let's just try it and see what happens. What's the worst that could happen, right? So I had this one lying around from the original set of speakers that were to be donated to this project, and this speaker, this came from like a 1999-ish cheap-ass desktop speaker set. Anyway, I put this in place of the Altec Lansing, and the noise immediately went down to this. That's as loud as it gets, by the way. So, in other words, it solved the problem to a level that I'm okay with. I'm fine with it. So, that's my solution, and I'm going to get, again, the RF beads. We're going to put those on a bunch of stuff to see if it helps. Or ferrite beads. That's what I meant to say, ferrite beads. That is what's going to happen. Okay, let's move along. So, I did say that I was trimming things out. Like for example, I put these pieces of wooden dowel in position here. And that is to trim out the multi-card reader. I put this piece of trim here to hide the gap between the board and the power supply. And I also added this piece right here. This is just a block of wood, and what its job is to hide some of the cabling that's behind it that goes up to the control panel. Pretty simple. Didn't cost any money to make that. I just used some scrap wood, cut it, sanded it, and popped it in. And that's pretty much it, guys. It's done. I'm actually gonna go over to my employer's office, my office where I work. I'm going to install this. I'm going to mount it up on the wall. And as I mentioned earlier, I have this rail here that will serve as a mounting rail. Basically, it hooks on to a bolt or a screw that goes into one of the... I'm going to use not toggle bolts. They're called toggler mounts. And they use a combination of like a zip tie-like technology, and it's plastic, and it zips into the wall, and it doesn't go in or out. It's brilliant. I'm going to put 2 of those in, 3 feet apart. So they're going to land somewhere around here. And that's the plan. That's the plan. So, can't wait to do it. This is going to be really cool. But that's it, guys. We're done. Oh, yeah, I don't know if I talked about this or not, but I had to put this here to cover the wiring in this box, and that's just hot melt glued in place in 2 spots. It can be removed if need be, and this is looking good. So installation is the reverse of the removal. Pick up the plexiglass, drop it into the slot. That, and drop in the pegs. Couldn't be simpler. And that is my very first custom PC case. I have never built anything like this before. I learned a lot of things. I had to make a lot of changes in the process. And I spent almost $0 on electronics to make this. The only electronics that I purchased were the fan controller, which was purchased strictly out of aesthetics. I needed something over here that lit up and blinked. So that is what fit the bill. That was $14. I bought the monitor from Goodwill, or no, I bought it from Savers. That was 14 bucks, I think I paid for that. It was the only widescreen one they had. So that's the one I bought. I bought the fan. That was $5 or $10. But all the money I really put into this went into materials like wood, screws, hardware. Some of it I had, some of it I had to buy. Dowels. I got cat hair in my mouth. The most expensive part was the plexiglass. That's $30 a sheet, and because I screwed up the first one, strictly by accident, I was looking for a piece of plexiglass for that fan controller cover over there, and I grabbed the wrong piece and I cut it up, and I immediately realized what I had done. At that point, I realized I just doubled my plexiglass expense from $30 to $60. That smarted. That was a lot of money to just throw away. But here we are. It's done. And I can finally sleep at night.